Hello everyone, today we're going to do an example question on titration. Okay, so now let's look what we have. Okay, so let's start reading. We have 25 ml and 0.150 molarity. Okay, so you have a volume, have a concentration about hydrochloric acid. Okay, so what is it? It's HF. Okay, so it's a weak acid. Okay, so again, this is coming from, you know, your strong acid, strong bases, so that should be straightforward. That's a weak acid. And then you keep on reading. I also have an NaOH. Okay, and then that's what? That's your strong base. Okay, so first of all, you know you have a weak acid and the strong base titration problem. Okay, and then the next thing to you go, I need to see which region this question belongs to. Okay, so then let's keep on reading. The question is saying, okay, what is the pH equivalence point? This question is nice. It's telling you where is that. Okay, so it's telling you equivalence point. To you, equivalence point should be translated into moles of the hydronium ion equals to moles of hydroxide ion. Okay, so that should be translated into this information. Okay, and then that's gonna help you, right? Okay, so you have that, and then you go. I have the volume and concentration of the acid. I have. Let me highlight it out for you. Okay, so you had the volume and the concentration for the acid, and then you have the concentration for the base. So you realize in order to deal with moles, you're missing with the volume. And then you already know, because at equivalence point, the moles imply the moles of the hydronium ion equals to moles of the hydroxide ion. So actually you can use this information to figure out the volume first. Okay, so the first step will go. So we're gonna figure out the volume of the hydroxide. Okay, the volume of hydroxide needed to be added to this titration in order to reach equivalence point. Okay, so this is also a very important skill to have for titration. Okay, so that's the first thing you need to calculate. You go, okay, so I can use this information now. Okay, so I have the moles, so I'm gonna go the moles of hydronium ion or equals to equilibrium. Okay, at the equivalence point. Okay, so you're gonna have it equals to the concentration. Okay, so then you go M times V. Okay, so then you have 0.150 molarity. So that's mole over liter times 25 ml. I can convert it into liter. Okay, so that's what we can do. So now let's cancel out some unit. This cancels out, liter cancels out. You have moles at the end, so that's perfect. Okay, so this value turns out to be 0.00375. Okay, so it's 0.00375. Okay, and then let me just double check the number. Okay, so I'll do it. So you can pause the video and then I'll do it together. So you're gonna have 0.15 times 25 divided by 1,000. Okay, so 0.00375 moles of the hydronium ion or the acid. Okay, and then you're gonna equals the moles of hydroxide ion, and that's good. We can use now. They'll have the same amount because it's at equivalence point. Okay, so this will be equals to 0.00375 moles, and then you know molarity, which is given from the question, so you can calculate the volume. Okay, so the volume will be the volume of this hydroxide you added will be the moles divided by the molarity. Okay, so the moles will be 0.00375 moles over the molarity, which is given from the question, is 0.15. Okay, so you do this calculation, you'll get liter, which turns out to be 0.025 liter. Okay, so that's what you have. Now you have the volume of both, and then now you can see one more time, if you recognize we are dealing with a weak acid strong base titration at equivalence point, okay, as we already talked about, you will know, okay, at equivalence point for weak acid and equivalence point at weak acid and strong base, what you really have, you will just have a salt, okay, so this is the salt you have. In our case is NaF, okay, so this is the salt, okay, and then turns out to be you're just calculating the pH of a salt solution, okay, and now of course then you'll be able to need to find out the concentration, okay, so but at least you know what to do, okay, so then that's all you have, and then the next question will be how do you calculate it. So let's start with again writing out our reaction equation. So you have sodium hydroxide and you have HF, okay, and you're gonna have sodium fluoride and H2O, okay. Again, let me draw our titration setup, okay. So you're gonna have this the burette, right, okay, and then you're gonna have your Erlenmeyer flask, okay. Inside here you have your HF, okay, you're titrating with an AOH, okay. So one more time, at this moment you add quite amount of the AOH and which neutralize out the HF, okay. So that means what do you really have in here? What do you really have in here? Okay. At this moment, the hydrogen ion and hydroxide ion are gone, but you have the sodium ion, and you also have the fluoride ion, right? This is what are the things floating. Of course, have water molecules. I'm just drawing two, okay? And the rest you can draw more, but I'm just trying to show you what's really here in your Erlenmeyer flask at equivalence point, okay? So then what are the species going to affect your pH? Sodium ion? No, not really, right? Because it's a cation of a strong base. So it's what? It's pH neutral. It's pH neutral, okay? So really, one ion going to affect your pH will be fluoride ion, okay? So now I'm going to write out our reaction, okay? So right with water, going to have HF, and then you have the OH, okay. So from here we need to set up our S table, okay. So our S table, then the problem will be what's the initial concentration of this fluoride ion. Of course it's coming from sodium fluoride, so will be the next question will be how you calculate the concentration of this sodium fluoride, okay. And then what is it? Okay, so that matters how many moles you produce from your acid-base neutralization reaction. As we said, everything turns into the salt. So the moles you had, we calculated right over here, right? The moles, okay? So the moles, since it's a 1:1:1 ratio, okay? So that means you will have the same amount, 0.00375 moles of the sodium fluoride produced, okay? And then you need to divided by the volume at this time, at this moment, at equivalence point. What's the volume? You have that 0.025, that's your acid, and you also added the same amount of the base, okay? And then you do this, you get your concentration, which is going to be 0.075 molarity, okay? So that's the concentration of NaF, and also equals the concentration of fluoride ion will equal to that. So I'm gonna put this number right over here. Okay, so that's how you get that. And this will be what? The rest will be 0, 0. Alright, you're so familiar with this process. Okay, so I'm gonna have this down. Okay, so when you express the K for this, actually it's a KB because you see you have hydroxide ion. Okay, so it's gonna be X times X, 0.075 minus X will equals to KW divided by KA, since KB is not directly given. Okay, so let's see what's the K value. K is right over here, 3.5 times 10 to the power negative 4. 3.5 times 10 to the negative 4, you do this, it will be 2.875 times 10 to the power negative 11. Okay, small approximation, so really you're going to have x squared equals to 0.075 times 2.875 875 times 10 to the power 11. Okay, if you recognize, again, this is something I don't like to do, but for the text purpose, if you really don't understand, or because the short time period, you can memorize this. Again, I don't encourage this, but again, this x turns out to be what? X squared equals to, what's this? That's the initial concentration of your salt. Okay, so the salt initial concentration, okay, and then you times the Kb value, okay, and then Kb, how do you get Kb? Kw divided by Ka, okay, of the acid, and that's what you have. And then what's the x value gonna be? Square root of this, the salt concentration, initial concentration times Kw divided by Ka, that's your Kb. So you get this, you can solve for the x, okay, and the x will be, you taking square root of all this, will be 1.468 times 10 to the power negative 6, and then that's x of what? Matching, go back, the x matching with OH. So this is a OH concentration, okay? And then if you take a negative log, so that will be POH equal negative log of 1.468 times 10 to the power negative 6, and then you get a number as 5.83, okay? And then that's our POH. We want to know the pH will be 14 minus POH will be 8.17. Okay, one more time. Once you get the answer, remember, as soon as you recognize at equivalence point, you have this salt, which is a weakly basic salt, right? Okay, so how did you know that? Because you have what? The fluoride is fluoride is the conjugate base of a weak acid, so that's gonna make the solution basic. Okay, so if your solution, this solution is basic, the pH will be bigger than 7. Okay, so as I said, even before you finish with a real number, you should already know that number should be in the range bigger than 7. Okay, so this is how you do this type of question. So you need to recognize what you're dealing with, and then since you already know how to deal with it, and then you can just carry out the calculation. Okay, so this is the end of this video, and I hope this is helpful.